Students, welcome to online classes for Diploma 5th semester EE 503 AC Motors. As you know that we have seen previously synchronous motors in details of its construction, working principle, performance characteristics, some numerical problems also we have done. In this lesson, we are going to learn another very famous and interesting machine is induction motors. The induction motor is generally used every day in our life. Before going to our topic, let us introduce myself. My name is Dr. C.H. Adaya, a senior lecturer in Government Polytechnic, Husnabad. Today's topic is 3-phase induction motor constructions. In last classes, we have seen the synchronous motors, starting methods of synchronous motors, application of synchronous motors, and merits and demerits of synchronous motors also we have seen. Today's topic we are going to cover. On completion of this period, you would be able to know one is the classification of AC motors, advantages of 3-phase induction motors over other motors, the construction of 3-phase induction motors, and finally production of a rotating magnetic field in the air gap. Now, classification of induction motors. As you know that previously we have seen AC motors are classified into synchronous motors and asynchronous motors. Here asynchronous motor is nothing but induction motor. This induction motor, what we have seen, all motors are classified into two types. What we have seen, just recollect. So, our machines, electrical motors are classified into DC motors and AC motors. Now, the AC motors further classified into, one is the based on different factors. One is the synchronous motors, another is the asynchronous motors. Synchronous motors and asynchronous motors. Now, the synchronous motors further classified. So, here last class we have seen synchronous motors. Now, asynchronous are further classified based on its whether it is a single phase or 3-phase, and based on the own type, that is based on the rotor type. So, we classified squirrel cage rotor and slip ring rotor machines. Now, asynchronous motor, mainly asynchronous motor is the induction motor. So, here induction motor is further classified based on the phase, based on the rotor wound, and this is classified based on the phase, whether this is a single phase induction motor and three-phase induction motor. Now, whereas coming to the rotor type, one is a squirrel cage rotor and wound rotor, that is we can slip ring induction motor. So, these are the classification of motors. As we know that the motors or DC motors is mainly works based on the DC motor principle, and it takes only a DC supply to run this motor. Now, whereas coming to the already secondary level you have seen. Now, coming to the AC motors are another is a synchronous motor and asynchronous motor. So, that means here synchronous motor is runs at a constant speed, whether run at synchronous speed or 0 speed. At synchronous it runs, rotor and stator synchronized each other, runs at normal rated speed irrespective of load. So, its motors, what are the applications already we have seen. Now, coming to the induction motors, asynchronous motors, generally induction motor. It works based on the induction principle. What do you mean by the induction? We will see later. Now, based on the induction principle, so it is further classified based on the number of phases, whether single phase or three phase. And based on the rotor, stator is the same, but rotor may be changed. Two types of the rotors we are using here. One is the squirrel cage rotor, another is the slip ring rotor. Okay. So, what are this one? We will see in details with the help of figures. Okay. Now, coming to the our topic, here the induction motors. Okay. So, induction motors classified based on the one is the single phase motor, another is the three phase motors. Now, further it is classified into, here you can see here what has happened. So, we have seen the induction motors classified based on the here. So, one is the based on the phases, the single phase and three phase, and based on the rotor, whether it is squirrel cage and wound type rotor. Okay. So, let us see in details in this main of induction motors. Okay. Now, after that, so before going to this one, so we are going to see what are the induction principle. Before that one, what is the electromagnetic induction, and before that one, who is the founder of this machines. Okay. So, we know that our forefather is a Faraday's laws. So, what is meant by the Faraday's laws of electromagnetic induction? Then after that, so what type of the materials can be employed in construction of electromagnetic machines? Okay, we will see it so in details. Now, let us see the basics of our theories. What is this one? Do you recognize this person? Yes, is a Michael Faraday, our forefather who invented this Faraday's laws. What is meant by Faraday's laws of electromagnetic induction? What type of materials can be employed in construction of electromagnetic machines? If you know this idea, basic idea about these two laws and magnetic materials, already you have seen in materials in first year level, then you can easily understand what is the purpose of the silicon materials and what is the need up to laminations of machines. Now, what do you mean by the Faraday's laws? The Faraday's laws of induction describes how an electric current produces a magnetic field, and conversely how a changing magnetic field generates an electric current in a conductor, as we know that. So we know that you are very familiar Faraday's laws of two laws generally. First law, whenever a conductor cuts the magnetic field, it induces an EMF in the conductor, that is known. In second law, the induced EMF in the conductor is directly proportional to the rate of change of flux linkages, that already you know. Here induction principle. So what is the induction principle? That means here what he is saying that the Faraday's laws of induction describes how an electric current produces a magnetic field. As you know that one conductor, whenever is current passing through this conductor, and there is a magnetic field developed around the conductor, already you seen in school levels. Okay, that is how electric current produces a magnetic field. Conversely, if how a changing magnetic field generates an electric current in the conductor, that is known as induction, or we can say, so this is mainly invented in 1830 by our English physicist Michael Faraday. Okay, now the magnetic induction makes possible the electric motors. So based on these induction principles, we have nowadays using so many machines like electric motors, generators and transformers. These are the vital role plays in our electrical fields. Okay, the magnetic induction makes possible the electric motors, generators and transformers that form the foundation of modern technology. By understanding and using the induction, we have an electric power grid and many of the things we plug into it. Okay, now what do you mean by magnetic materials? Now we have seen that here. So what is the definition of the Faraday's laws of electromagnetic induction? You have seen what he is saying. The scientist saying that an electric current produces how an electric current produces a magnetic field, and conversely how a changing magnetic field generates an electric current in a conductor is first found after the Faraday's this conductor. So if you are seeing, if you want to see, here you can see it. Now what is saying that? So for example, this is a one coil through which there is a current is flowing, I current, then it induces a magnetic field around the conductors. This conductor. That means due to the electric field, it produces a flux magnetic field. Now at the same time, conversely, if this magnetic field flux, change in flux d by dt, change in flux, it produces a current in the conductor. He found in 1830 years. That is known as the induction principle. For a simple example, I will give the one simple example, just like you see here. What is happened here? For example, there is one person, your classmate, is a new admission, and here another person is a senior. He is a good person, good attitude, and another person you can see here. So this is another person, is a last bench person. The character and attitude is bad. Now this new person, if makes friendship with a good person, What are the qualities of the good person? Maybe get into this person within 6 months. But he never says you do this, you do this, just like. But by simple following, closing and friendshiping, if get the some qualities from this good person qualities. This quality, that means how he got the good qualities from this person is not preached, is not teached any qualities. Just observing this person activities, he learn few good activities. So this process is known as the induction process. Induction process. There is no continuity between the induction process. Induced the good qualities in that person. In the first case. For example, in second case, you take it. If unfortunately this person the make friendship with bad person, after 6 months, the person may get the bad qualities due to the induction. Really, this bad person may not teach any qualities to this person, but simply this person observed what are the activities of this bad person daily. He habituated. After 6 months, he becomes a bad quality person. How he got to this bad qualities? Due to the induction. Okay, as we know that in Telugu, ఎవరైనా 6 months స్నేహం చేస్తే వాడు వీడైతాడు, వీడు వాడైతాడు అంటారు. Similarly, here what is happened? The normal person, if you are friendship with a good quality person, he has got a good qualities. Otherwise, if friendship with a bad quality person, he may get the bad qualities. How he get is due to the induction. For example, you take the electrical thing, another electrical thing. For example, you can say, so for example, there is a one line, if you are observed, there is a 133 kV line. And so here 33 kV line. So there is a line, so flowing here, 33 kV line, 33 kV HT line. Now, for example, here another line is also under this one, as we know that the 11 kV line or 400 volts. So this is a 400 volts line. So what has happened? Here 400, just like is a phase, phase, phase and neutral. Similarly, phase, phase, neutral, phase. So this is a line. The crossing the or along this line, the distance may be nearly 1 or 2 meters. Okay. Then what is happened? If I want to do the work nearby this pole, what to do? Have to switch off the supply here or this here. I have to do work here. So now, so here is the one house require the new connection. You want to give the supply to here. So you switched off the supply at AB switch at DTR. Here also isolated at the junction. Now what has happened? There is no power in the line. The lineman who works on the line, at the time of the end work, he may get severe electrical shock and fall on the ground. Why? He electrocuted is subjected to the electrical shock. Why? Here is not AB switch is opened. Here this lines is also opened. But how he got the electric shock? There is no current in the line. There is no input from this side. There is no input from this side. But he got the electrical shock. How? So mainly due to the because, so this line which is flowing current in the HT lines, due to these lines, these conductors and these conductors. So what will happen? The current is flowing the 33 kV line, it produces a flux. The flux which is the linked with these conductors. As per Faraday's laws of electromagnetic induction, the flux is a AC in nature, alternating nature. It links with the aluminum conductors, the 400 volts LT line. So due to this one, induces the voltage in the line. This EMF may be get shock to this person. So EMF induced nearby conductor due to the current flowing other conductors is known as the induction principle. The EMF induced in the conductor due to the current flowing another conductor is known as the induced EMF. The EMF induced in the lines, nearby lines, is known as the induced EMF, that is a induction effect. Okay, actually there is no physical contact between this line and this line, but there is an air gap between the 2 to 3 meters. But even then he got electric shock. How? Nowadays you can see in papers, the lineman got electric shock. Sometimes it is by fatal death also due to the induction. Dear students, now you can got some idea what is the induction here and what is the induction, how the characteristics, the attitude changes due to the induction. Okay, so how this line is induced in the current induction. Okay, let us see. This is the definition of induction. Okay, now after that, so what are the different materials is required? So here the Faraday's laws of electromagnetic, after that what are the different types of the materials we require to used in electric motors. In all electrical machines can be used as a generator and can be used as a motor, already we know. Here we require it has a stator, it has a rotor. Stator has a stator winding, and rotor has a rotor winding. The winding is wound on a laminations on slats. Here also in the slats. The slats are made with the magnetic material. Okay, so magnetic material. What are those magnetic materials generally used in our electrical engineering? As we have seen in DC machines, DC motor, the poles is laminated. Poles is also laminated. What is the lamination thickness? We have seen 0.35 mm to 0.5 mm thickness. What is that required the laminations? To reduce the eddy current losses. And at the same time we have to use some silicon material, some good magnetic material. What are the good magnetic materials generally used in our electrical field? Generally, so here we are going to use it as soft magnetic materials generally used in all rotating magnetic machines. Generally, it is generally used in the fully processed silicon iron material is one of the topmost material. Fully processed silicon ferrous. And another one is also nickel and ferrous, NiFe. Also we can use as a magnetic material. And sometimes we can use also cobalt and ferrous. Alloy is used as a silicon steel. Generally, the cobalt iron lamination steels as well as the soft magnetic composites, that is known as SMCs, soft magnetic composites, and sometimes we can use the nowadays we are using the observed amorphous materials also we can use amorphous, just like it is the thickness is the just like papers, our notebook papers, amorphous materials. So these are the different type of the magnetic materials used in our electrical fields to make stator and rotor laminations. Okay, the soft magnetic materials are used in rotating magnetic machines. The investigated materials includes mainly the fully processed silicon iron material and nickel iron materials, cobalt iron laminations, steels, as well as the soft magnetic composites, and amorphous magnetic materials are generally used in our electrical engineering. Okay, so dear students, these are the some main important points. Now let us go to our topic. Now after that, what do you mean the induction? Now we have seen. So induction we have seen. What is that one? According to the Merriam-Webster, what is saying that induction process by which an electrical conductor becomes electrified when nearby charged body. So this is a one conductor. Now I placed another conductor nearby this one. Now when the current flows through this conductor I, it produces its magnetic field along the conductor, and in the air gap it covers the nearby this conductor. The process by which an electrical conductor becomes electrified when near a charged body. Here this is a charged body and this is a electrified, or we can say that a magnetizable body becomes magnetized when in a magnetic field or in the magnetic flux set up by the magnetomotive force. That means suppose there is a one magnet, you can say it here, one magnet is placed north pole and south pole. Nearby I placed the one iron piece, then iron piece also becomes a magnet. That is the induction. How it becomes? Due to the induction. Physically there is a contact between the iron piece and our magnet, but there is an air gap between the two. Even then the iron piece is in the magnetic field itself, then it becomes as a magnetized material. Or we can say that, so what is the reason? It is an induction. An electromotive force is produced in a circuit by varying the magnetic field linked with the circuit. So change in magnetic field also produce the current EMF induced in the conductor due to the induction. These are the three references we can say that is the induction. Already we have seen how the one new person becomes a good quality person and bad quality person by simple following that person principle. In our electrical fields, so we have designed these three topics. Okay, so as you know that already you have seen DC machines, synchronous machines and transformers. So let us, your very interesting topic, that is the transformers. Let us take one example how the induction takes place from primary to the secondary without any physical contact between the primary to secondary. Similarly, you can say we can analyze this into our induction motors. Okay, so let us see. Now we can see here what is happened here. So here this is a transformer core magnetic material made up of this alloy, already we have seen, and this is a laminated. When AC supply is given to the primary, it produces a magnetic field here, and this magnetic field will flows through the iron core. and links with the conductor materials. Okay, then what is happened? So this whatever the induced EMF in the secondary, that is given to the one bulb load, the bulb will glows. Actually, you can see it, primary and secondary, there is no contact between any physical contact between the two wires. So whatever the primary is coming and secondary is coming, physically is isolated. But even if supply is flowing through the primary, it induces the EMF in the secondary due to the induction effect. Same analysis can be done in case of the induction motor. This primary is nothing but this stator. So we can see the stator windings, this stator winding. And the secondary is nothing but it's a rotor, blue color one. Here air gap between the primary and secondary, here air gap between the stator and rotor. Okay, you can see here what is happened. This is a stator. Okay, this is the stator winding. Now this is the rotor and here is the rotor windings. And whenever the three-phase supply is given to here, it produces the rotating magnetic field that passes through the air gap and links with the stationary rotor parts, conductors. Then it induces the EMF in the rotors. That rotors induced EMF is the current. So when it is in case of a squirrel cage, the short circuited bars, it induces it. So EMF, that current flows, the flux is developed. This flux and this flux interaction takes place, the rotation will takes place. That will see basic principle. Now here you can observe one thing, how the transformer transform the energy from the primary side to secondary through the air gap. Similarly, here is also we provided the stator to rotor energy is transferred due to the induction effect only. So there is no physical contact between the primary and secondary. Similarly, there is no physical contact between the primary and secondary conductors. Okay, so we can see this. What is the physical part? You can see normally. What is that one? So transformer, you can see it. This is the transformer, and this is the motor. Internally, what is happened? We are already seen. Okay, so this is a basic idea of induction principle. Now let us see what is this one. What is this? Already you have seen some machines. Please tell it. Is it the DC motor or is it the synchronous motor? No. Then what? You know that the DC motor, it requires the DC supply, and synchronous motor we require the DC supply and the AC supply. But here we require the only AC supply is required. Can you expect? Or you can see it. So this motor generally used in agriculture pump sets, in our houses also. You can see. So what is this one? You can observe this type of the pumps generally used in agriculture pump sets for our fields. Sometimes we can use this type of the motors also for lifting up the water from our water sump to over a tank. Or sometimes latest we are using this type of the pumps also, submersible pumps. So what are the basic principle? What can you say it? Yes, this is the induction motors. So based on induction principle it works. Stator and rotor consist, and whenever the current flows in stator and induces EMF correspondingly in the rotor, and stator flux and rotor flux interaction takes place, torque develops and the torque will rotate the rotor. That is a basic idea of motor principle. Okay, now we can see the comparison between our synchronous motor and induction motors. That means asynchronous motor and synchronous motor. The physical point of view is the same, but internally if you are observed, the electrical circuitry changes. Okay, so you can see here asynchronous motor, that is the induction motor. Synchronous motor, as already we have seen. Okay, so by externally we are seeing this is the same, but it requires the 3-phase AC supply and DC supply also is required for the synchronous motor, which can run at synchronous speed, at constant speed. Whereas the induction motor require only 3-phase supply only, no need of DC supply or excitation. But it may not run at constant speed. If load added on the rotor, the speed will falls. But whereas the synchronous motor, if you added the load up to some extent range, it will run at a synchronous speed only. Okay, these are the some comparison between the two. Now, what are the advantages of this one? Now, comparing to the other motors, what are the other motors? Whether it is a DC motor or synchronous motor, what are the benefits of induction motors? Okay, if you know the benefits, then you are going to get the interest to know how this can be benefited comparing to the other motors. Okay, here generally this induction motors nowadays we are using the 75 to 80% the motors are induction motors only, comparing to the other DC motors and synchronous motors. Those are the very costly, whereas our induction motor is a very cheap and best motor and a very rugged motor. Okay, what are the advantages? Let us see. Now, so advantage of a 3-phase induction motor is a very simple. So, construction is a very simple, extremely rugged and almost unbreakable construction, especially a squirrel cage type. What is the squirrel cage type? We will see later. What is the squirrel? Udta bone. We will see later. Now, another advantage is the low cost and high reliable. So, it is the low cost and it is the unreliable, it is a very highly reliable. And another advantage is the has a sufficiently high efficiency motor. Now, at the same time, so no need of the brushes required in normal running condition and frictional losses are reduced, where in case of the DC machines we require the brushes, as well as in slip ring, synchronous motor also we require the brushes to slip rings. Here in this case no need of slip rings or no need of brushes business. So, frictional and windage loss, friction losses are very low, and at the same time it has a good power factor also and require the minimum maintenance because it is a rugged machine. It can work at any weather condition also. At the same time, so it no need up to start other motors just like the synchronous motor. It is a self-starting motor. Okay, it starts from rest and needs no extra starting motor is required to run the motor. These are the few advantages of induction motors. Okay, so dear students, what are the benefits? You can see it. Our induction motor. So, what are the induction motor? So, you have seen induction motors already. So, here you can see it. What are the benefits of this one? Now, our induction motor first one is a very simple first point, extremely rugged, almost unbreakable construction, especially in squirrel cage induction motor. low cost is very low, high reliable, and efficiency is also very high, and no brushes is required, and a good power factor, and no need of maintenance, and it will quick self starter motor. These are the benefits of induction motors compared to the synchronous motors as well as the DC motors. That's why nowadays we are using in daily life, so 80 to 90% of motors are only these induction motors. Okay, so that is the required. Now let us see, so what is the induction motor, what is the internal parts of induction motors, how each part is participated to run the motor. Okay, so let us see. Now here you can see what do you mean the induction motor. An induction motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of stator winding. What is saying that here it has a stator, here is a rotor. Okay, stator has stator winding, this is the also having the winding. Here given the three-phase supply. An induction motor is an AC electric motor in which electric current, here electric current in the rotor current needed to produce torque is obtained by electromagnetic induction from the magnetic field of stator winding. That means whatever the current required in the rotor for production of torque is taken from the stator field through air gap. That is known as the induction motor principle. An induction motor can therefore be made without electrical connection to the stator to rotor. There is no connection between the stator and rotor connections. Okay, that is the idea. Now if you see inside how the cross sectional area of the motor, so what are the different parts inside, you can see here. Now you can see this is the stator, it has a rotor, this is similar to the all motors, it has a yoke or frame, and it has a stator, it has the rotor, now you can see, and it has the end rings, and there is a fans also provided here, that is a cooling fans. Now there is a shaft and there is the terminal box, you can see here for the stator connection. These are main parts of a induction motor. Okay, what are the main parts? So you can see main parts are the stator and the rotor. To assist the stator and rotor, we are going to provide bearings, drive-ins, non-drive-ins, that is the cooling air fans, enclosures, and so everything we are provided here. Okay, now if I open this one, so you can see the what are the different parts inside. You can see here, it is clarity. This is the rotor. Okay, this is the rotor, this is the stator, and this is the bearings, end rings, couplings, and you can see same fan to cooling purpose, and end rings, the terminal boxes. Everything is open. Now you can see the stator as a stator core and stator winding also. Rotor having the rotor bars inside. This is the squirrel cage. Okay, let us see one video regarding this one. You may get some idea. Okay, now, so let us see it. We can see one video regarding to the induction motors. So, in the animation you can see it. Who is this one person? The Tesla, the forefather. So, 90% of the industrial motors are induction type motors. So, because already we have seen the advantages and disadvantages. Now, you can see how the rotor, stator is a stationary part and rotor is a rotating part. Now, so power input given to the stator winding, it has a stator slots, closed, semi slots. It's all of the laminations already you have seen in DC machines. There is a winding, lap winding or wave winding or mush winding, 3-phase winding, distributed winding. When 3-phase supply is given to the 3-phase winding, there is a rotating magnetic field is generated, already you have seen in synchronous motor. Okay, it is generated the speed and rotating at a synchronous speed. Now this rotating magnetic field links with the stationary rotor. For example, you can tell how the rotating magnetic field is generated in stator. You can see, as we know that whenever the current passing through the conductor, it establishes the magnetic field. Now these three R phase, Y phase, B phases are placed 120 degrees at each other. Now, so what is happened? So at a time, one phase is current phase is a maximum. After 120 degrees, another phase is a maximum. After 120 degrees, another phase is a maximum. So already we calculated, we have found that how the vector changing the angle. That means it is a rotating in a synchronous speed. You can see in the RYB the wave vector, phasor vectors. Okay, so that is the rotating magnetic field rotating in the air gap at the synchronous speed. What is the synchronous speed? Ns is equal 120 F by P. Now, so based on this one, so there is a rotating magnetic field is generated. This rotating magnetic field links with the stationary rotor. Rotor has one conductor. You can see here is one rotor is placed here. Okay, so here one rotor is placed here. So this is a squirrel cage rotor. Just like so, this rotating magnetic field when links with the stationary this rotor conductors, and it also produces its EMF in the rotor conductors, because rotor conductors are short circuited at both ends, and it induces EMF in the rotor conductors and it produces its own flux. This flux you can see it, and this rotor flux and stator rotating magnetic flux interaction takes place, the torque is developed. Due to the torque, rotor, whether stator has to move or rotor has to move, but stator is a stationary part. The rotor is placed on the bearings. At the same time, you can see how the laminations takes place in a rotor also. Okay, you can observe rotor slots is not parallel to each other. It is skewed by some angle. What is the purpose? We can see later. Now, you can speed up the rotor depend upon the what factors. As we know that the formula N is equal to formula 120 F by P. Okay, that is the 120 F by P. Now, you can see here. So, N rotor is equal to synchronous speed. So, now once the rotating magnetic field rotates in a air gap at a synchronous speed, the induced EMF in the rotor also produces a magnetic field, and this field also try to catch the synchronous speed, that is the Ns. But due to its frictional and windage losses, due to some weight, it may not reach the synchronous speed. That means it is a synchronous Ns, always the rotor speed is less than the synchronous speed. For example, 4-pole machine, the synchronous speed is 1500 rpm, but our rotor runs less than the 1500 rpm only 414 or 440 or 1440 rpm. That is difference between the synchronous speed and rotor speed. We can say the slip. The percentage slip can be expressed ns minus nr by nr into 100. Now here what are the advantages? You can see no permanent magnet is required, no brushes is required, no commutation problem, or it is a self started easily. Okay, and easy speed control. Frequency, we know that frequency 128 by P, AC frequency we can control easily. Number of poles we can control the speed of this machine. So we have the plenty of the advantages comparing to the DC machines as well as the synchronous machines. Okay, so here we can know that synchronous speed is directly proportional to the frequency. Then by changing the frequency we are going to produce a different magnetic fields. Okay, the rotor speed is directly proportional to the speed. Now you can see how the rotor is rotating due to the torque developed due to the stator magnetic field and rotor magnetic field. Okay, then now we can see the one practical example of the electric car. The single speed car, you can see the, so same induction motor can be used in our latest vehicles, electric vehicles also we are going to use our induction generators. What do you mean by the induction generators? In this case the rotor speed is greater than the synchronous speed, then it becomes a synchronous generator. Okay, so if the speed is less than synchronous speed, it will act as a motor. If the rotor speed is greater than the synchronous speed, then it will be a synchronous generators. Generally this can be used in windmills also. So it has a different applications you can see here. Okay, is a plenty of applications we are going to see in our daily life. Now let us summarize what we have seen in this session. We have seen that first one, that is the classification of motors. These motors classified based on its basic principle, whether AC supply or DC supply. Based on the DC supply is DC machines and AC machines. And AC motors also for the classified synchronous machines and asynchronous machines. The asynchronous machines are induction machine. Here the induction motor also can be used as an induction generator. There is a best example is a windmills. The induction motor classified based on its number of phases and types of rotors used in it. Based on the phases, whether it is a single phase for the small HP purposes, fractional HP to some small amount of HPs, for the low power usages, for the more powers we can use the 3-phase induction motors. And based on the rotor we can use it, whether it is the squirrel cage rotor or own type of rotors. What are these rotors? We will see in the immediate next class. And we have seen that what is told by our Michael Faraday's and what are the different materials used in our electrical machines, how they are useful to reduce the iron losses in our machines. And generally we have seen that the silicon iron alloy and nickel ferrous alloy and cobalt ferrous alloy generally used, and nowadays we are using the amorphous magnetic materials also in our motors machines to reduce the iron losses. At the same time we have seen that what do you mean by the induction? The induction, the process by which an electric conductor becomes electrified when near a charged body. We have seen different. At the same time we have compared our induction principle machine, that is a transformers, with our induction motor. How the energy transformed from primary to secondary in case of transformers, and how the energy taken from the rotor from stator. And we have seen some advantages of induction motors with comparing to DC machines and synchronous machines. As we know that is a low cost and high reliable and high efficiency and cheapest best and rugged motors. And speed also we can vary, and instantaneously the speed will vary and will. So it is a self-starting machine. 3-phase induction motor is self-starting, whereas a single-phase induction motor is not self-starting. We will see later. Next, we have seen what are the different parts in a induction motors and what are the each part application also we have just briefly have seen. Exploded view of 3-phase induction motor also we have seen. At the same time, some animation induction motor also we have seen in YouTube. So courtesy to that video also. Dear students, we will see a remaining part in the next session. Okay, thank you for listening.